All right, this is problem number 31 on page 192, chapter 8. Okay, so it wants me to make a scatter plot. So I can make a scatter plot. I'm going to go to my plot number 1, and it's on the scatter plot, and it's actually on. I'll push on, make sure it's on. Right? But I want it to do list 3 and list 4, and you got to pay attention that you make your right list the x-axis and your right list the y-axis. That will be important to know. You have to know which is the dependent variable and which is the independent variable. So I happen to know that I put L3 was my x, so I go list 3. And I know that L4 was my y, so I go second 4, there we go, that. And I push enter, and now I should be able to go zoom 9, and there's my scatter plot. Okay. It look kind of like that? It's, if you have like an outlier, you might want to go back and check your data. Yeah. If you have an outlier, you might want to go back and check your data. Because, you know, like a minute ago, I entered in something wrong. You know, when it came out wrong. Okay. Describe the association between age and price of a used Corolla. Oh, let's go magic bowl, huh? Oh. No, that's not the magic bowl. What's the? We're just describing this scatter plot. Who wants to describe it? Okay, Hunter.
Okay, so as the car segments get older, the price of cars is going down, so it's in a negative correlation. Right?
Yes. Okay. So we have direction, form, strength. When you're describing a scatter plot, direction, form, strength. Okay. Direction, negative. Form, I say it looks pretty linear to me. Are we okay with linear?
Yep.
Linear. It's either going to be linear or non-linear. Strength, I'd say it's pretty strong. That makes sense? Okay. Strong. Good for us.
If you said medium, would it be wrong?
No, it wouldn't be wrong. No. And if you said weak, that would be wrong. Because that's clearly not weak.
Yeah.
Right? And honestly, if you looked at this, well, no. If you looked at this and you said it was curved, I'd probably have to argue with you a little bit. But I will tell you, whatever I give you is going to be linear. Right? Because if it's curved, that's the end of the problem. And I don't want the problem to end. I want the problem to continue. Does that make sense? Right, so I gave you an answer, right? The form is going to be linear. Okay. So do you think linear model is appropriate? Yeah, we just decided that, right? Yeah. Computer software says that r squared is equal to 0.894. What is the correlation between age and price? Well, the correlation, if you remember, is r. So I just want to take the square root of r squared.
0.95.
Right. What does it come out to be?
0.95.
Equals 0.95. Now you might get r squared if they say, what is r squared is frequently described as a percentage. So it might say r squared is 89.4%. But correlation, r, is always between -1 and +1. It's always a decimal. So you have to remember that the 89.4% is the same thing as 0.894. When you're figuring out r is always going to be between -1 and +1. Can't be any bigger or smaller than that. Make sense? Okay. Okay, the next says, explain the meaning of r squared in this context. So, we talked about this a little bit yesterday. R squared is describing the variation in the data. So, you want to say, and I'm not going to make too much of an issue of this right yet, right? You want to say that that 89.4% of the variation in our model, of the variation is 89.4% of the variation is in our model 1 minus 89.4%, which would be 10.6% of the variation is in the residuals. Okay. R squared is taking our correlation and it's squaring it. It's essentially another way to measure how strong the model is. Okay? So what I'm saying is that 89.4% of the model here is described by my correlation line. So if 89.4% of it is described by my line of best fit, my correlation line, that only leaves 10.6% to be described by the scatter in the residual. Yes?
So with the correct answer, just do like 89.4% is accounted for, like you said yesterday?
Yeah, but 89.4%, just make sure you say of the variation.
Okay.
Of the variation. Yes,
If we just said that, that would be correct.
that would be correct.
Okay.
It's 89.4% of the variation is accounted for in the model.
Yes, that is correct. Yes.
When you're explaining R, like in comparison to R squared, like what's the difference? Would you say the same thing if asked what's the correlate, what's explain R in the problem? Would you still say, well, 0.95%?
Well, if it says what's R, you're going to say it's 0.95.
It says like explain the meaning of R in this context. Would you say the same thing?
No, you wouldn't.
So it's different.
If they say because R is really the slope of our line of best fit when we're looking at it in z-scores. So it's a little bit different concept. I'm not going to ask that question, so don't worry about it right yet. Let's see how they ask it here. Okay. Why doesn't this model explain 100% of the variability in the price of a used Corolla? Because it's not a straight line, right? If it was to explain 100% of the variation of the price, that means that my R would have to be 1. So I'd have a perfectly straight line in my scatter plots. Yes?
Would we be able to say that it's because of the 10 to other 10.6%?
You can say that. Yep, that'd be fine. Yep.
Wait, so you're saying that it's not because not all the points are on the line?
Yep.
Oh, okay.
Yep. If all the points were on the line, we'd have a correlation of 1, and we'd have an R squared of 1, right? You take 1, square it, you get 1, right? Anything off the line is going to change your R squared. Yeah? Okay. All right, so that's 31. Now let's go to 33, which is more used cars. Okay. Use the advertised prices for Toyota Corollas given in exercise 31 to create a linear model for the relationship between the car's age and its price. Okay, and we're going to walk through several steps to do that. So I need to find the equation of the regression line. How am I going to find the equation of the regression line? Yeah.
Y hat equals, right, B naught minus B sub 2x?
Close.
B1x.
Plus, not minus.
Oh, plus.
Okay. That's the general form of the equation of a regression line, but I need to find it for this guy specifically. Yes.
Should we use a calculator or do you want to show
I'm going to make you do it both ways. Oh no, this is not hard to do. Okay, so let's.
Can we just do it by hand?
Well, we're gonna do it first by hand, and then you're gonna check it on the calculator. Okay, so there's several pieces of data here that I don't have. I don't know what my V sub 0 is. I don't know what my slope is. Okay. I do know what my R is though. My R, in fact, I'm going to show you if you remember. My R is 0.95. We calculated that from r squared, right? So my r is 0.95. I want to get from r to the slope. I want to get from r to b sub 1x. Yes, something.
Like R equals, I mean, Y, no, R times S Y over S S.
That's exactly right. That's gonna get me to the slope. That's gonna get me to b sub 1. But now you have a problem. I haven't been given my standard deviation of y, and I haven't been given my standard deviation of x. How am I going to find those?
Use 2 points.
Nope.
You change everything to Z squares?
Well, now what I'm going to do is I'm going to use the calculator, right? So I have one list, right? My L3. So you remember if I go to stat, calc, and I want one variable stats, right? The very first one. And I want to do it for L1, L3, second 3, and I push enter. What do you know? What do you know? My L3, which is my x value, gives me, I have a mean, let's write this here, I have a mean of 6, and I have a standard deviation of 3.71. I took that one right there, SX, and I rounded up to 3.71.
What did you do?
Pardon me?
Where did you look?
You go to stat,
Second
calc,
mode stat.
And then
Well,
what was it?
let's just do it
and
again.
then 1 bar stat.
Oh, okay.
I do my Y, which I know is my L4. So let's just do it again. I'm gonna press stat. I'm gonna go calc. I'm gonna go 1 for variable stats, and I want to now do it for L4. I press enter. Well, my mean is 67.75, and my standard deviation is 36.24. We okay with that? Okay. So this is L4, right? And if you think about the numbers here in the book, right? Well, yeah, 6,700 looks like it's about kind of the average price of all these cars that's being sold. And you know, your eyeball looks pretty close, right? Standard deviation, I'm going to trust them. You know? Yes.
Where did you, okay, so did you, so when you set up your information, did you put like L1 for like 1, 2, 3, 4, and then put like how there's 2 for 1?
Yes.
You put like 2 separate ones?
Yes. My edit list looks like this: stat, edit, L3 and L4. So
I didn't
One.
do it that way,
that-
but I
that-
still got the same looking graph.
I have to look at how you did it, but I'll look at it later. But this is the way it should be done. Your graph looks identical.
My graph looks like yours, but I just did it not that way.
Okay.
I did like 1, 1, 2, 2.
He did that.
No, but he went like he put 1 through 13, and
No.
then how there's 2 for 1. He did
No, he
like
did
No, no, no.
1 and
No, look. Look. 1 year. There's only 1 for 2. Oh.
Okay.
Okay.
So.
All right.
Okay. I don't know.
So what I just did was I got this is my x value, my x variable, the years, and this is my y variable, the prices. And what I just did by getting the variable stats is I got the mean of the years and the standard deviation, and I got the mean for the prices and the standard deviation. Well, now I can go ahead and I can calculate what's the slope, right? Because I have my sy and my sx. So my slope is, so this is going to be my b sub 1 is equal to r, which is 0.95, let's erase it, make it nice, 0.95 times the standard deviation of y, which is 36.24, divided divided by the standard deviation of x, which is 3.71, what's that equal to?
928.
928?
Yes, it is. Okay. 928.
0.95 times 3624 divided by 3.71, 928. That's my slope of my regression line. You had a question?
I realized it now. I was thinking R wasn't in the equation, but R is B.
R is B1. Yes.
Do we multiply in the x and y afterwards? The
Well,
lines?
okay, so now I know, so far I know that y hat is equal to b sub 0 plus 9. In fact, let's do this more effectively. Price hat is equal to b sub 0 plus 928 year. Okay, so far so good? Okay. I still need to find b sub 0. Yes, thank you.
So, when you plug that into the equation, it's like R then equal B1,
Well, not r doesn't equal b1.
or like your slope is B1?
Your slope is b1.
You need R to find your slope.
So here's the equation is y hat equals b sub 0 plus b sub 1 x. Okay, if I was to change that to, if you're thinking about y equals mx plus b, I'd have y equals mx plus b, but you have to see that it's kind of reversed here. The m, which is our slope, is b1. And the b, which is our y-intercept, is b sub 0. Yes?
I'm just confused about that formula because I thought it was that R equals like the standard deviation times the mean times like, and then divide, then you multiply it. Like, you know what I'm saying?
I'm not sure what you're saying. I'm going to put this here. I'm going to put slope.
It looks incomplete. B1. Why do you? Oh, that's the slope.
That's just the slope. The slope is my r times my standard deviation of y divided by my standard deviation of x. That gives me the slope in my regression line.
So the B1 is you just use standard deviation to figure it out?
Yes.
Oh.
Please excuse the interruption. Please dismiss varsity separate at this time. Please meet from the stand. Good luck, ladies.
So far so good. All right, let's finish it off. I need to figure out how do I get b sub 0.
Well, you can use, I guess, Y. Oh, is this
One more
the
time?
same?
Okay, I'm gonna do what you just said. So what I have, my predicted price is going to be something plus my slope times the year. And I have one data point that I know for sure. Nope. 0, 0 if it was standard deviations.
1.
I know that the mean is going to be on the regression line.
Oh, your mean?
I know that the mean of each of my variables is going to be right on the regression line. It has to be. Okay. So I know that the mean price, let's get rid of this here a minute. Control F. Okay. My mean price is 67.75. That's going to equal b sub 0 plus 928 times my mean of the year, which is 6. Because I know that the mean has to be on the regression line. That's the one point that I know for sure is going to be on my line.
Does it matter what mean you take?
Ask the question again, I'm not sure.
Matter what number from the X and Y position.
Are you okay? Okay. Good. So now I can make a little calculation. Okay, so I have, I'm going to subtract this number from both sides of the equation. So I'm going to have 6775 minus, parentheses, 928 times 6. So my B sub 0 is 1207. That's all that I'm left with. Did everybody follow my algebra there?
Yeah.
Okay? You sure? Okay. So I have B sub 0 is equal to 1207. So that means the equation of my regression line should be price hat is equal to 1207 plus 928 year.
Year hat?
Year hat is what we're predicting. Year is what we know. This is our independent variable. This is what depends on the year. Okay, does that make sense, everybody?
Yeah.
Okay, I'm going to pause this. All right. So what I'm going to do now is I'm going to go to the calculator. And I'm going to go stat, calc, and I'm going to go to 8, which is my linear regression. That is my model, my linear regression model. And I'm going to go second L3, I want L3, comma, and L4. And I'm going to test now to see whether the model that the calculator gives me is the same as what I just calculated here.
How did you get line
Pardon?
8.
Yes, linear regression, LinReg. And I haven't done this, so this is it might be totally wrong, and then I've blown a bunch of time. Let's try it. Pretty good. Pretty good. Okay, this is y equals a plus bx. So they're telling me that y is equal to my a. Oh, they're saying 12,319. Uh-oh. Minus. I made a mistake someplace. Bad me.
Yeah.
What
I
is-
told it. I just told it.
We don't even need to check it.
Well,
Wait, it's 924.
924.
924.
Pretty close, but I'm off by my numbers are wrong. My signs are wrong. I'm off by too much. Yes,
I don't put R squared or R
I'll fix yours. I gotta update your calculator.
Wait, are we really close?
Well,
It says on here that our R is negative.
I know that. Oh, it says that our R is negative.
Because don't we have a negative line?
We do have a negative line,
So wouldn't ours be negative?
so R would be negative. I hate when I do this. You know that?
Me too.
You too, huh?
Okay, so our R squared is a negative.
No. Our R squared is a negative. Of course, it can't be negative. R squared can't be negative because
It's squared.
it's squared, right?
That's
So that was our mistake. Was right here. Was that this should have been a negative number,
9.5.
negative 9.5,
Why? Oh,
because it's negative line. Duh. Everybody see what happened here?
Yeah.
Okay, so let's work it through and see what happens. Okay. So this would have been. That would have been a negative.
It's now negative.
So now this is negative 928, which works, right?
It's not right.
Well, it's close enough. 928, 924, same amount. I'm not, it's because we're rounding. So this now becomes minus 928 year. So this becomes a minus sign. This is actually going to work out okay. Actually, this is going to be a good example, right? So now I have, that's what not to do, 6775 plus 928 times 6, because I'm adding that to both sides now, and I get 1243.
Wait.
Okay. What I have was 928 times 6. Originally, I was subtracting it from both sides, but since it's a negative number, now I'm adding it to both sides. And so my b sub 0 isn't 1207. My b sub 0 is 12,343. So 12,343. And actually now we're really pretty close.
That's how you check the work.
That's why you check it. That's why I have you do it on the calculator too, as part of the exam. So this is totally acceptable. The calculator says 12,319 minus 924 year. We say 12,343 minus 928 year. Close enough, right? And the only reason that they're different is because we rounded. That's the reason that they're different. Does that make sense? So this okay? Can everybody do that? Maybe.
Yes.
Just keep going. I can always split it up later. All right. So it says explain the meaning of the slope of the line. So our slope is 928. What does that mean? Negative 928. What does it mean?
It means every year that the car has however many years old the car is, it depreciates $928 a year.
Did we hear that? Yeah. Does that make sense? Right? My slope is negative 928. It's times the year. Every year I go along, my car is going to be worth $928 less, on average. Right? That's my prediction. Good with that?
Yeah.
Okay. Isn't this interesting, really? I mean, come on. This is practical stuff. This is okay. Explain the meaning of the intercept of the line. So this is my intercept right here, 12,319. What's that mean? Where's my eraser? What's that mean? So let's draw it out. We know I have my line is going this way, correct? Right? And at some year over here, the price would be worth 0, like my car now feels sometimes, like it's worth nothing, right? So what does this mean right here? Brand new car, right? Zero years old, and this is 0 years old, and this is, I don't know, 15 years old, whatever. Make sense? Now, sometimes your y-intercept is not going to make any sense at all. Right? And you just have to kind of use your common sense. Like, for example, like if you did a regression line for like weight of babies, by month, right? I mean, you might get some like negative number up here, for what if if the weight of babies per month, it would be a positive slope, right? Mm-hmm. Right, and it might actually, intercept the y-axis, kind of like negative, right? But you can't have a negative baby weight, So you just have to. So a lot of times your y-intercept is really not going to make that much sense, because really what you've developed your data from is figures that are more in a different time frame or a different interval. Right? So don't worry about it too much. If it doesn't make any sense, don't be afraid to say, y-intercept here doesn't really make any sense, and leave it at that. That's okay. Is that making sense a little bit what I just said? It's a model. It's not the truth. It's just a model to help us predict stuff. Okay. If you want to sell a 7-year-old Corolla, what price seems appropriate? How am I going to figure this out?
Plug that number in for a while.
No.
Very good. I plug 7 in for my year, right? I work out the numbers. It'll give me a price that I think it should have. So it would be 12319 minus 924 times 7.
Wait, Mr. James.
558.51. Yes.
Do you want us to do the equation that the calculator gave us, or the one that we thought of?
I don't care. It won't make any difference. It's a couple dollars. seatbelts. Okay. Yes.
So like on the, I did the worksheet that you gave us with the heights and the weights of the people.
Mhm.
And one of them did come out to be like a negative baby weight, it was like for this work. But one of the numbers was like maybe 4 or 5 pounds off. Would that be too much of an error? Because I did it with the calculator's formula, and it was like it came out 5 pounds different than the answer said. Would that be too much?
Okay, so let me put it to you this way. If I'm asking you to make a prediction, use the calculator's formula. Okay? One of the questions is to check how your formula comes out compared with the calculator's formula. Right? And I'm asking you, is that close enough? Well, now, my original calculation here, where I had plus 928, well, no, that's really not close enough. That's a serious mistake, right? As we can see, it made a big difference in our answer, right? But you know, if it looks close enough, say yeah. But then use the calculator to make your calculations. Use the calculator's formula to make your calculations. Just that way, we'll all be kind of on the same target.
Okay.
All right.
Calculator is different than the answer.
Yeah, but you know, in the big scheme of things, not that big of a deal. Okay. Okay. You have a chance to buy one of 2 cars. They are about the same age and appear to be in equally good condition. Would you rather buy the one with the positive residual or the negative residual?
The negative.
Oh, very good. I have to think about those hard. Yeah, we want a negative residual because we want to buy one that's below the line here because we want to pay a cheaper price. If it's above the line, it's going to be a more expensive price. And so we want a negative residual. Yeah.
Wouldn't the negative residual mean the predicted number was above the line, right? Because that would be an overestimate.
So let's see. Let's think it through. Okay.
Oh, I see.
Y minus y hat, right?
Yes.
Okay. So if we have a negative residual, if we have a negative residual, it means that our y is less than our y hat.
The y hat was an overestimate.
The y hat was an
Then
overestimate.
which one is on the line?
Y hat is on the line.
Oh, okay. Oh,
Y hat is our predicted value, right? And so our negative residual would be here, which would mean a lower price. Does that make sense? Are we good with that? Okay. Aren't you sorry you didn't spend more time studying this? It's so interesting. It's just so interesting. It is really interesting. You see a for sale. Oh, this is an important question. You see a for sale sign on a 10-year-old Corolla, stating the asking price as $1,500. What is the residual?
Is that a question you would ask?
I don't know if that's right.
How would you calculate?
You plug 10 into the equation and then use that number into the price? Or
Okay, so I have 1243, 12,343, clear that. 12,343, let's clear that. 12,343 minus 928 times 10 years. I come up with a price of $3,063. That is my predicted price. Okay, they're selling it to me for how much did they say? $1,500. What's the residual? The residual is y minus y hat, right? My actual price is $1,500. My predicted price is $3,063. So my residual is whatever that turns out to be, 1,500 minus 1,663. Negative 1,563. That's my residual on this particular car. Yes.
Oh. Like if the y is less than the y hat, then it's negative, right?
Yes.
So then wouldn't you possibly think 1,500 is more than
1,500 is less than 3063.
Never mind, I can't. Don't reach this.
Okay, you got it?
500.
You see it now?
It's not it.
Okay, I'm sorry. Okay. Would this regression model be useful in establishing a fair price for a 20-year-old car? You think so? Well, let's try it. I have 12,319 minus 924 times 20. It gives me a negative price.
If you think about it, your R2, isn't it like, what is R2?
89%? Right.
It's like really goes to only a little bit off of 100%, and your R2 determines how close you are to the predicted price.
Okay, attention. Okay, this is an interesting question. So the question asked, does the model work for a 20-year-old car? And we said, well, I don't know, like 20 years in here, and it's telling us that the price for the car, according to our linear regression model, will be negative 6161. So in other words, if I was buying a 20-year-old car from Ashley, she not only has to give me the car, she has to give me $6,100, which is a hell of a deal, right? So we'll take that. I'll take that car. Right? But the reason why it doesn't work, even though our linear regression model gave us the 89% R squared, is because all of our data is between 1 and 13 years. So really, our model is modeling cars in that time interval there. Sometimes you can use it to predict out farther, but frequently you can't. That make sense? Yeah. So that's where our data came. Now, if we had data for like 20-year-old cars, then we probably have a different regression model. Our R square would probably be a little bit worse, right? But yeah.
I'm just confused, like, why we're multiplying 20 and 94 at the same time. I mean, are we supposed to be multiplying 20 by the answer we get of what 12, 319 minus 924? Because I mean, in the order of operations, we kind of use your answer.
Well, no, the order of operations here is, so here's my formula right here, right?
I'm so lost right now, I'm sorry.
Okay. Do you see the formula here? Right. So y equals 12,319 minus 924 times the year.
Okay. Okay.
Does it make sense? Okay, so our order of operations, we're okay up there. All right, yes.
So the answers are coming out to be negative because that basically the equation, I mean, not the equation, but like, that's not like a fair price. So like, no matter what negative it came out to be, like, throughout this amount of years, like, the car.
Well, it kind of means that the model really isn't good for that many years away.
Okay.
That's what it means. And that's what the question is asking. Would this regression model be useful in establishing a fair price for a 20-year-old car? No, not really. All right, so was this a good exercise here?
Yeah, it was. Great, thank you.
It was helpful.